Hi everyone, my name is Jeremy Seltenfuss. I'm a professor here at Colorado State University. I work on wetland and river ecology and restoration, and I'm happy to go through an example project for you today. So real quick, before we jump into the case study of this wetland restoration, we kind of need to figure out what a wetland is and go through some wetland restoration basics, and then I'll take you through this restoration of a wet meadow for the National Park Service. So what are wetlands? Well, they're pretty much as they sound. They're wet lands. This is one of the technical definitions. Lands transitional between terrestrial and aquatic systems where the water table is at or near the surface for enough time to support plants adapted to life in saturated soil conditions. So this really goes through three basic characteristics of wetlands. It talks about water levels, the hydrology. It talks about saturated soils, so there's particular soil conditions. And then it talks about vegetation, vegetation that is adapted to living in these saturated soil conditions. Now, hydrology is what I often focus on in a restoration context because hydrology really drives wetland form and function. It's the primary driver of vegetation composition, of animal use, and of soil formation. And most importantly, wetland types differ in their hydrologic regime. So hydrologic regime is really talking about water levels through time. So here we see this figure of water table depth along the y-axis, where 0 is the ground surface, and through time, through any given year, May, June, July, August, September, and October. And we have three different wetland types shown by those different colors. So a fen is a peat-forming wetland that's saturated throughout the whole year. A floodplain is associated with a river, and then a wet meadow can exist in various landscape positions, but each one has a distinct hydrologic regime. Now, in terms of a restoration process, if we were coming up to some degraded wetland or an area of land that used to be a wetland, there's three primary questions that I often ask that we all should ask. So what did the area used to be? What impacts occurred to bring it to what it is today? And how do the proposed actions restore that altered site? So what did the area used to be? This could be in terms of what it used to be in terms of wetland type, or its water source, or hydroperiod, that hydrologic regime, or what types of vegetation used to be there. When we ask about what impacts occurred to bring it to what it is today, we might be talking about hydrologic alteration. Maybe water was diverted across the land. Maybe it was purely vegetative. The vegetation was removed. Maybe it was a fundamental change to the landscape. Here we see an image of a wetland being completely filled in, so a total change in the structure of this landscape. And then how might the proposed actions restore the altered site? We really should be proving this with data. So if we have a site that used to be in this top image, it used to be vegetated, sort of this flat wet meadow, it was subsequently filled in with material, we would think, well, we should pull out that material, and we would want to prove it with data both before we do the restoration so that we can design an effective restoration strategy, and then prove that what we did was actually effective. So here's an actual example. This is a site that I worked on a number of years ago. It's a small wetland that is kind of outlined in this light blue color. And there is kind of this hillside that had been historically wetland, but it was filled in to create stables. And the national parks wanted to restore this back into wetland. They just didn't know really how much material to remove. And so we instrumented this site with groundwater wells, and this is the actual data from this site. So water table depth in feet along the y-axis and through time along the x-axis. And we have 5 different wells in the area needing restored and 1 well in our reference site. And really all we have to do is use this data to think about these 3 questions that I posed earlier in this restoration context. So what did the area used to be? Well, we're lucky here because we have an immediately adjacent reference site to compare to. So we have an example of both the vegetation and the water level, depth of water level from the ground surface right next to our area needing restored. So that's associated with that line. Then what does it look like now? Well, we collect data on the vegetation. It's mostly upland weeds and lots of bare ground. And here are the hydrologic conditions, the hydrologic regime of this site through time. And what is immediately apparent is that the water levels in the area needing to be restored fluctuate at the exact same time and moments when the water levels in our reference site fluctuate. And this is really a good indication that the water source and the water flow through the ground hasn't been impacted. It's simply the water depth from the ground surface that needs to be changed. And so what will it take to be restored? Well, we simply, in this particular site, for well 4 there, we need 4.5 feet of excavation. And it should bring this hillside down to mimic the conditions in our adjacent reference site. Now, when we restore hydrology, your restoration strategy really should be linked to the reason why the hydrology was altered in the first place. And this requires a fundamental understanding of different wetland types. Remember, a wetland is not a wetland is not a wetland. There are different wetland types. Here we see hydrographs from vernal pools, bottomland hardwood forest, and a temperate forested wetland. If you are trying to create a vernal pool, but you get a hydrograph of a temperate forested wetland, well, you're just not going to make a vernal pool. So it's important to understand where these wetlands exist on the land surface. So here's a pretty classic diagram of wetland locations across the landscape. You have depressional features, you have riverine features, lacustrine is on the edge of lakes, you have slopes and wet flats, and then estuarine systems. And really what you want to do is link your wetland type to its position on the landscape. So if you're talking about a vernal pool, well, that's a depressional feature. You don't want to be positioning this in, say, a riverine landscape if you're trying to create a vernal pool. Whereas a bottomland hardwood forest is a riverine. So if you're nowhere near a river and you're trying to create a bottomland hardwood forest, you're probably going to have a pretty tough time. And then a temperate forested wetland, which occurs in the southeastern United States fairly commonly, is a wet flat. Vegetation, of course, once we restore our hydrology, we want to figure out what plants we want to put back in our site. This is a commonly used schematic showing really just that plants are adapted to life in saturated and wet conditions, and different plants are adapted to different conditions. So if you have more of a xeric, a drier end of your wetland, you want to make sure to plant species that are tolerant of drought, are tolerant of conditions that don't always have high water availability. And then on the other side, if you have completely ponded conditions, you really need those species that are adapted to life in ponded conditions. Now that's fairly intuitive, and you hear that and say, well, yeah, of course. But it's pretty common to see a wetland restoration install plants in either areas where they shouldn't be or in complete wetland types where that plant isn't associated with out in nature. And so you have to ask yourself, what plants, what species do we want to install? Where should we install them? And then when should we install them? Do we install them when it's real wet in the spring, when it's more dry in the fall? It depends on what species you're talking about. Okay, so that's an 8-minute primer on wetland restoration, and I'll take the remaining time to tell you about a case study restoration that I've worked on for the last 10-ish years. It's ongoing. This is just some preliminary data. And this is at Florissant Fossil Beds National Monument, west of Colorado Springs in Colorado. This is a wet meadow restoration. So Florissant Fossil Beds is a national monument. It's an area up in the mountains west of Colorado Springs. It's got some really amazing fossils associated with it, old fossilized sequoia stumps and lots of invertebrates. It was homesteaded in the 1800s. This is a picture of the original homestead site with the kind of the area of interest, the wetland of interest in the background. And through that homesteading activity, they manipulated the landscape as many homesteaders did, and they took some wetland conditions and created ponds for their livestock and for hay production. And what happened over the subsequent years was just this series of erosive events that led to channelization and gullying of this wet meadow that really never had a channel to begin with. So we ask again those same three questions. What did the area used to be? What impacts occurred to bring it to what it is today? And then how do the proposed actions restore the altered site? So let's go through those questions together. So what was the area like prior to disturbance? There's lots of ways to potentially answer this question. We've used both reference areas, assuming that an unimpacted site nearby is similar to what our degraded area used to be, sort of a space for time substitution, but also historical imagery. And these together sort of lay this foundational story of what this site used to be. So our reference area is a wet meadow. It's dominated by sedges in the genus Carex, herbaceous vegetation, and it really has no channels through it. It's just slow groundwater flow. If we look instead then at historic imagery, here is a Google Earth image from recently. If we were to turn the time back, this is back to 1938, and we could see that even in 1938 sounds like a pretty old image. We already have seen a little manipulation of the land surface to create this stock pond. So they dug up some earth, they created a small dam, berm, to create this pond, maybe for cattle, maybe for hay. So that's 1938. Fast forward to 1956, and we have some major recontouring of the land surface. Larger dams, creating these fairly sizable ponds and reservoirs behind them. And really a fundamental change from a groundwater flow system to a surface water system. And then in 1975, we see no more water being held in these systems. And that's because if we were to zoom in, we would see some channels having been eroded around these dams. And that leads us to today, where the dams are mostly hard to see, but the channels are very obvious. And those channels are likely draining the land surface, which we'll get to with data in just a little bit. So here's one of these dams, fairly sizable, lots of material, and leading to these gullies, these channels around it. And those channels are really unstable banks. There's no real rock in the soil profile, indicating that it would be a riverine system. These are wet meadow soils. There should be really no channels here. So it seems likely that the gullies are draining the meadow, but we really should prove it with data and allow that data to drive the restoration design as well. So we took some survey gear out to the site. Here it is looking back down towards that homestead. And we surveyed the whole landscape such that we could take aerial imagery and overlay topographic data onto it. Really call out those topographic features, both the dams, the impoundments, and those channels. We then installed some groundwater monitoring wells across the whole landscape. These are meant to record water levels through time, and each of these red dots are where groundwater wells went in. The reference site is at the lowest part, lower left of your screen. So just looking at some hydrologic data from this transect, we're really wanting to compare water elevations across the landscape. So the highest elevation of water is to the left, which is pretty far away from this river channel, and that's telling us, or this gully, and that's telling us that groundwater is coming in from the hillside, which is kind of what we'd expect. It's coming from snow melt that has seeped into the ground. So water comes into this landscape, and rather than staying fairly near the ground surface, it quickly starts declining down towards those channels. And in the channels, in the gullies, are where the water level is the lowest. So it is telling us that these gullies are draining this wet meadow, which makes us kind of want to restore this landscape. And restoration would include filling in these gullies that seem to not be a natural part of this landscape. Now we wanted to help the National Park Service. This would be a pretty huge project, And so we wanted to show them that this would be an effective way to go. And in 2012, we started this pilot project where instead of filling in all the gullies, we took the material from these impoundments that were made, and we placed that material inside the channels, sort of acting as small other impoundments within the channel to make the channels not effective anymore at draining the landscape, just to see if the water levels in the adjacent wet meadow would increase. So this is what it looked like once we placed that material inside the channels. It just didn't allow the channels to effectively drain that landscape anymore. And here is a picture of some yellow equipment in a wetland, classic wetland restoration photo, manipulating the ground surface. Restoration is, of course, a pretty invasive procedure, but here we're really trying to fundamentally alter the processes happening here to restore this landscape. And here's a fairly recent Google Earth image showing this kind of created pond from the impoundment in the channel. So it's working again to back up that water, but we needed to see if the water levels in our groundwater wells responded to it, and they did. So here's two wells. The orange is right in the middle of this wetland, and it's showing a dramatic response, an increase in almost 1.5 meters of water level, showing a very dramatic response for the groundwater levels in response to blocking up these channels. And in the blue, that was an area kind of further away. It doesn't seem to be impacted all that much from restoration, so it's potential that this restoration is having a more localized response in this wetland, but I think time will tell in terms of the vegetation, how the vegetation also responds. The full-scale restoration, we're using this data to indicate that filling in these channels is the right way to go. It does restore water levels, at least locally. So we're hoping to remove this large dam on the south side of the meadow and use that material to fill in all of the channels throughout the valley. And then we'll plant the area with species grown from seed collected on site. And that should take place in maybe 2021. We're getting the permits right now and the funding right now. So I look forward to presenting those results in a few years. But anyway, thanks for your attention, and I'd be happy to take any questions over email. If this has inspired you or you have any questions or concerns, feel free to email me at any point. Good luck. Take care.